June 6, 1944 Normandy. The beach is a graveyard of machines. Sherman tanks burn like metal furnaces, their tracks twisted, their armor peeled open by German guns. The invasion that was supposed to be unstoppable has stalled in the mud. Every few minutes, another tank tries to push forward through the hedgerows and dies in flame. On one of those beaches lies a wreck. Its name is Fury, its crew scattered, its mission abandoned. Smoke rises from the broken hulk, its turret half buried in the earth. To any rational soldier, this tank is finished, just another carcass in a sea of failures. But one man refuses to walk away. Sergeant Curtis Culin, a mechanic from New Jersey turned tank crewman, stands in the silence of gunfire and ash. He isn't an engineer, nor a man of rank or reputation, just a field mechanic, a man with a torch, a wrench, and an idea. They called him crazy. Maybe he was. For days, he had watched tanks die not from superior German armor, but from the ground itself, the ancient Norman hedgerows. Those thick earthen walls, built over centuries, were killing machines in disguise. Every time a Sherman climbed over one, its underbelly, the weakest point of its armor, lifted toward the waiting Germans. One shot, one kill. Every time. Now, standing before the burned shell of Fury, Culin saw something the generals didn't. The problem wasn't the enemy. It wasn't even the tank. It was the way they fought nature, trying to go over what should be cut through. Somewhere between the sound of the surf and the echo of machine guns, a spark caught fire in his mind. He pictured steel teeth, crude, improvised, welded to the front of a tank, not to climb, but to tear, not to rise, but to devour. A mad idea, born from wreckage, a mechanic's rebellion against the impossible. By the time night fell, he had already sketched it in a small, oil-stained notebook, a weapon no manual had ever described. He didn't know it yet, but that idea, drawn by a crazy man with a welding torch, would change the course of the Normandy campaign and rewrite the logic of armored warfare forever. Steel would soon learn to think, and a broken tank would become legend. In the summer of 1944, 6 days after D-Day, the Allied advance in Normandy had frozen in place, not because of the German tanks, not because of artillery, but because of the hedgerows. The maps had called them bocage, innocent enough, a word that implied bushes and fences. But to the men who met them head-on, they were something else entirely. Each hedgerow was a wall of earth and root, ancient and unyielding, some rising 15 feet high and just as thick, built layer by layer over centuries by Norman farmers. Beneath the greenery was not softness, but compacted soil, stone, and gnarled roots older than the country that had sent these men to war. To the American tankers, these hedgerows became the true enemy. Each one formed a natural fortress, a perfect ambush line for German infantry, a labyrinth of death where every field became a battlefield. When a Sherman tank reached a hedgerow, it faced a cruel choice. Attempt to climb it and expose its thin underbelly to enemy fire, or halt and become a stationary target. For days, this mechanical graveyard grew. Tanks burned, crews perished, medics worked until their hands shook. The U.S. Army's great momentum, built from the beaches of Omaha and Utah, had hit an obstacle not designed by generals or scientists, but by farmers long dead. In the headquarters tents of Allied command, the frustration was palpable. Plans drawn in ink were now dissolving in mud. The expectation was to reach Saint-Lô within days, to push inland, to bring the war out of the hedges and into the open plains of France. But progress had slowed to a crawl yards, not miles, per day. Each hedgerow had to be conquered separately, each victory paid in metal and blood. For the men on the ground, the hedgerows were not just physical barriers, they were psychological ones. You could hear them groan under their breath when the next wall of green appeared ahead. Tank crews had begun to dread the moment the ground rose before them. They knew what came next, the lift of the nose, the tilt of the chassis, the sudden exposure of the belly armor. Then the crack of a German Panzerfaust, the explosion, and the flames. Those who survived often came out burned, screaming, sometimes silent. To many, it felt like a curse that the very soil of Normandy was conspiring against them, but to Curtis Culin, it was a machine problem. Before the war, Culin had worked in a small garage in New Jersey. He was not a scholar or a soldier by nature. He was a man of bolts and bearings, of pressure and leverage. He understood one simple truth. Machines always obeyed physics. If something didn't work, you could always find the reason: friction, force, balance. As he watched Sherman after Sherman die on the same patch of earth, that mechanic's instinct started dissecting the battlefield. The tanks weren't failing because of courage or command. They were failing because the design was meeting the wrong kind of terrain. The US Army had built its tanks for mobility: broad plains, fast advances, open ground. But Normandy wasn't open. It was a patchwork of fields stitched together by medieval earthworks. The Sherman's greatest strength, its speed, was meaningless here. Its smooth hull, ideal for gliding across Europe, now turned against it. Every time a Sherman climbed, its center of gravity shifted backward, the tracks lost traction, and its belly lifted high enough to expose the vulnerable undercarriage. The armor underneath, barely an inch thick, might as well have been paper against a Panzerfaust or an 88mm shell, and the Germans knew it. They waited, they aimed low, and every time a tank tried to rise, they fired. This cycle repeated itself so often that some Allied commanders began to consider bypassing the hedgerow regions entirely. But retreat wasn't an option. The bocage stood between the beaches and the open countryside, and the open countryside meant Paris. Something had to break the pattern. Inside that chaos, amid the despair and exhaustion, the Allied belief system itself was being tested. The faith that technology could solve everything, that America's industrial superiority was unassailable, was fracturing. The tanks that symbolized U.S. power were being humiliated not by German science, but by dirt and roots. In military briefings, officers spoke of tactics, reinforcements, artillery coordination. But on the ground, it was the simple mechanical reality that ruled. The machines could not do what they were designed to do. And when machines failed, men died. Culin's worldview was simpler. To him, the tank wasn't just a weapon, it was a system of cause and effect. If the system wasn't producing the outcome you wanted, you had to change the mechanism. No bureaucracy, no debate, just steel and hands. To his fellow soldiers, this made him strange. That mechanic's at it again. They'd say, half joking, half weary. He was the kind who carried a small notebook everywhere, sketching in the margins, muttering equations and angles like a man haunted by machines. They laughed because war wasn't supposed to be about tinkering, it was supposed to be about orders and bravery. But Culin was neither philosopher nor dreamer. He was a realist trapped in chaos, and he was beginning to see the war not as a series of battles, but as a series of engineering problems waiting for solutions. The Allied army had millions of men, thousands of tanks, endless supplies. But in that moment, what it needed most was one mind that refused to accept the impossible. And on the edge of the Normandy fields, under the smoke of burning Shermans and the weight of failure, that mind was already working. In every war, there are moments when belief systems collapse, when doctrines crumble, and progress depends not on command, but on imagination. For the Allies in 1944, that collapse was happening in silence, not in the halls of command, but in the hands of a crazy mechanic staring at a broken tank and a problem no one else could solve. What came next would prove something far greater than victory in a single battle. It would prove that even in the most mechanized war in history, the decisive weapon was still the human mind, the only machine capable of reinventing itself. The contradiction began with a single observation, not in a report or a strategy room, but in the dirt. Sergeant Curtis Culin stood beside another burning Sherman, its treads still spinning uselessly, clawing air. The tank had died trying to climb. Every Allied design, every training manual, every doctrine told them to move over obstacles. The tank was the triumph of elevation to dominate terrain, to crush what stood before it. But here, in the hedgerows of Normandy, that logic had turned suicidal. Culin saw it as clearly as a stripped gear in an engine. The problem wasn't the enemy, it was the assumption. If you keep trying to go over, you expose your weakness. If you learn to go through, you become unstoppable. That single thought divided him from everyone around him. His crewmates, exhausted and numb, saw the burning hulks as inevitabilities, proof that Normandy was simply impossible terrain for armor. But to Culin, impossibility was a technical diagnosis, something to be measured, cut, and welded into submission. He began sketching during brief halts, his pencil scraping over the pages of his notebook, translating battlefield chaos into angles and force vectors. He wasn't thinking like a soldier anymore. He was thinking like a machinist, standing before an uncooperative engine. What if the tank could cut instead of climb? What if, instead of being defeated by the hedgerow, it used it as leverage, ripping it open from the roots? To most men, the idea was madness. To Culin, it was inevitable. He remembered the fields back home in New Jersey, how heavy trucks would sink in soft earth but could still chew through with enough torque and the right grip. The problem wasn't power. The Sherman had plenty of that. The problem was geometry, the shape of contact between machine and terrain. He needed a new interface, something sharp, something crude, something that could bite. In the midst of battle, surrounded by wrecks and wreckage, Culin began scavenging. From the twisted remains of German beach defences, the so-called Czech hedgehogs, made of steel beams, welded into cruel crosses, he saw not obstacles but opportunity. Those same shapes, repurposed, could form blades strong enough to dig into ancient Norman soil. That night, in a makeshift camp near the front, he brought his idea to Captain Samuel Morrison, his commanding officer. "Permission to requisition a wrecked tank, sir, one that can still move." Morrison looked at him, half amused, half incredulous. "What for?" "To weld blades onto it," Culin said flatly. "To cut through the hedgerows instead of climbing them." The captain laughed, not cruelly, but in disbelief. "You want to take a damaged tank, attach scrap metal to the front, and drive it full speed into a wall of dirt? That's your plan?" "Yes, sir," Culin answered, "because the current plan gets us killed." The room fell silent. Culin didn't raise his voice. He didn't argue tactics or theory. He just described the physics. When a tank climbs, its belly rises. When it tears through, its armor stays forward. The Germans can't shoot what they can't see. Morrison studied him. The logic was there, stripped of emotion, clean as a schematic. "Finally," the captain said quietly, "you have 48 hours. To most men, it was a death sentence disguised as permission. To Culin, it was ignition. He and a handful of welders scavenged the beaches where the first landings had taken place. Steel littered the sand, jagged, rusted, deadly. They cut apart German obstacles under the flicker of acetylene torches, working through the night, sparks flying against the cold wind. By dawn, 4 jagged prongs of hardened steel lay ready, each sharpened, reinforced, and precisely angled. They would be welded to the front of a Sherman, jutting out like the tusks of a mechanical beast. When the crew saw the creation the next morning, someone muttered, "Looks like a pig trying to mate with a porcupine." The laughter that followed was uneasy. Culin didn't smile. "Maybe," he said, running his hand along one of the blades, "but this pig's going to tear a path through France." Even Captain Morrison, inspecting the welds, couldn't decide if it was genius or suicide. "You've built your contraption," he said at last. "Tomorrow morning, we find out which one it is." That night, Culin couldn't sleep. He kept replaying the design in his mind, the weld angles, the thickness of the beams, the force distribution on impact. Every calculation was sound, but theory was a fragile thing on the battlefield. The only test that mattered came with fire and dirt. When dawn came, the tank battered, scorched, and reborn with its new steel fangs rolled into position. The soldiers gathered around to watch. It looked absurd, monstrous, primitive, and yet, for the first time in weeks, they were watching a machine designed to fight back against the land itself. Culin climbed onto the hull, his heart hammering beneath his uniform. In less than a minute, he would know whether he'd built salvation or a death trap. He gave the signal. The engine roared. 30 tons of steel lunged forward, not to climb, but to strike. The machine moved like an animal freed from its leash. Its steel treads crushed the soil, its engine growled under strain, and the 4 jagged blades welded to its nose shone with a faint metallic light. Before it loomed a hedgerow 6 feet thick, ancient and immovable, a wall of earth and root that had mocked every Allied tank since D-Day. "Driver, advance." The order came from Captain Morrison, but it was Culin's creation that obeyed. The Sherman lunged forward. The impact was brutal. Earth erupted in a violent spray. The entire tank shuddered, and for an instant it looked as though the beast had broken its own bones. Then, movement. Slow, steady, impossible movement. The blades bit deep. They split the hedgerow like a wedge through timber, tearing the soil apart from its base. Roots snapped with sharp rifle-like cracks. Stones flew in arcs of dust. And then, with a sound like thunder rolling through metal, the tank burst through to the other side. The soldiers who had gathered to watch erupted into cheers that felt half like relief, half disbelief. Weeks of failure shattered in an instant. The impossible wall had yielded to steel and fire. Curtis Culin didn't celebrate. He just stood still, hands trembling slightly from the vibration that still echoed in his bones. His machine had worked not because of luck, but because physics had finally bowed to reason. The principle was simple, brutally simple. By lowering the point of contact, the tank could transfer force horizontally, not vertically. Instead of climbing the obstacle, it impaled it. The energy that had once lifted and exposed its belly now drove directly forward, allowing the tank to maintain full armor toward the enemy. The welds had held. The angles were perfect. The fangs, as the soldiers began to call them, had turned the Sherman into something more than a tank. It had become a blade. Captain Morrison turned to Culin, eyes narrowed in disbelief. "Sergeant, how fast can you make more of these?" Culin hesitated. "With a crew of welders? 10 a day? Maybe 12? Morrison's expression hardened. "That's not enough. I'll get you 50 welders. You'll have 100 tanks ready by the week's end." At that moment, the battlefield shifted not by orders from generals or the arrival of reinforcements, but by one mechanic's improvisation. By evening, word spread through the division. The impossible hedgerows could now be breached. Crews gathered around the modified Sherman, nicknamed the Rhino. They touched the blades with cautious reverence, as though the steel itself had absorbed some kind of divine logic. Every soldier who looked at it understood what it meant: freedom of movement. Survival. The death trap that was Normandy's bocage had finally met something more ruthless than nature itself. When the Rhino went into combat the next morning, it wasn't a test anymore. It was war. The rain fell in thin, cold threads as the modified Sherman rolled toward a fortified German position. Culin was aboard, acting as a technical advisor. The driver, Corporal Jake Mitchell, gripped the controls, eyes fixed on the dark green wall ahead. Behind them, infantry waited for the signal rifles ready, breath held. At 100 yards, they saw flashes of muzzle fire. German machine guns opened up, stitching the ground in lines of dirt and sparks. "Keep steady," Culin said calmly over the intercom. "Hit it at 20 degrees. Let the blades do the work." Mitchell's jaw tightened. "Yes, sir." The engine howled. The Rhino struck the hedgerow with the full weight of 30 tons of armor. The sound was apocalyptic steel screaming, soil exploding, the air filled with smoke and pulverized root. Inside the tank, every bolt rattled, the vibrations clawing up through the crew's bones. Then, movement, forward motion. The hedgerow didn't stop them. It tore open under the tank's charge, earth and debris cascading around the hull as the Rhino broke through to the other side. On the far end, a German machine gun nest stared back in shock, too late to react. The Sherman's 75mm cannon fired point blank. The explosion obliterated the nest. The crew inside never even aimed. "Target neutralized." "The gunner," Tom Harrison muttered. Culin exhaled not triumph, but vindication. "It works," he whispered. "Under fire. It works." The infantry poured through the gap behind them, fanning out, clearing the position. What had been a death trap the day before was now a corridor of advance. By the end of the day, the Rhino and its crew had smashed through 6 hedgerows, destroyed multiple enemy strongpoints, and linked with another platoon that had been pinned down for days. When they returned, covered in mud and ash, the look in the soldiers' eyes had changed. They no longer saw a crazy mechanic. They saw a man who had forced the earth itself to yield. Within a week, fabrication orders came from higher command. The modification, officially named the Culin Cutter, was to be installed on every operational Sherman in Normandy. Welding teams were mobilized from engineering battalions. Beach scrap became a strategic resource. The beaches that once represented chaos and destruction were now a supply line of invention. Piles of German steel, the same metal once meant to stop the invasion, were now being repurposed to fuel it. Workshops sprang up across the French countryside. Sparks filled the night sky as welders worked in shifts under camouflage nets. Torches hissed, rivets clanged, and molten metal dripped like blood into the soil. Each modified tank rolled out with 4 crude steel prongs, simple, ugly, but perfect in function. To the engineers back in England, it was a marvel of field adaptation. To the tank crews in Normandy, it was salvation forged from wreckage. General Omar Bradley himself visited one of the modification depots. He found Culin grease-streaked, exhausted, his uniform half-burned from days of welding. Bradley studied the tank before him, touched the still warm steel of the blades, and smiled. "This," he said, "is what wins wars, not laboratories, not headquarters, but ideas like this. A simple, brutal idea that works." He turned to Culin. "You just turned the German defences into scrap metal, Sergeant. I'm recommending you for the Legion of Merit." Culin, still holding his welding mask, said quietly, "Sir, I just fixed a problem." Bradley grinned. "That's exactly what the best soldiers do." By late July 1944, hedgerow cutters became standard equipment across Allied armoured divisions. They weren't refined or elegant, they were crude, uneven, each one slightly different depending on the hands that built it, but their effect was universal. With the new modifications, Allied armour no longer slowed before the hedgerows. They didn't stop. They attacked, punching through barrier after barrier in coordinated formations. Entire German defensive lines, built to exploit the terrain, collapsed within days. For the first time since D-Day, the tanks of the US Army could breathe again. Culin's invention did not just change the mechanics of movement, it changed the tempo of war. The static, grinding advance transformed into fluid assault. Commanders began redrawing maps, reorganizing their strategies around a new, astonishing truth. The terrain that had stopped them could now be weaponized. Every tank that burst through a hedgerow carried his fingerprints, each weld, each angle, each scar of steel. The battlefield had become a workshop, and the workshop had become a weapon. But behind the industrial triumph lay something deeper, the revelation of a system that defined the 20th century. War, at its core, had always been an engineering problem. Every stalemate birthed a new mechanism. Every failure demanded a new design. The machine was not just a tool, it was an extension of the mind that built it. In the Culin Cutter, this truth became visible in steel. It was not a masterpiece of design. It was a statement of philosophy. That improvisation is the soul of progress. The same Allied industry that had built aircraft carriers and bombers now turned to junk and torches and still prevailed. In that moment, Curtis Culin embodied something that factories could not replicate: human adaptability, the capacity to think under pressure, to invent under fire. That was the anatomy of victory. A broken tank, a welder's torch, and a man too stubborn to accept defeat. By the time August came, the hedgerows of Normandy, once the graveyard of Allied armour, had become the road to liberation. Sherman tanks, bristling with steel fangs, carved their way toward Paris. The Germans, confused and demoralized, had no answer. Reports recovered after the war revealed their bewilderment. The enemy's armour now passes through the hedgerows without exposing itself. The method is unknown. Our defences are no longer effective. The Allies didn't just win ground, they rewrote the equation of war itself, and it had begun with a single contradiction: a crazy mechanic who dared to think that maybe the tank didn't need to climb. War rewards results, but it rarely rewards peace of mind. For weeks after the breakthrough, the hedgerows of Normandy fell one after another. The Allies advanced at a pace no planner had dared to imagine. Entire German regiments crumbled under a storm of steel. The impenetrable bocage was gone. And at the centre of it all stood a man who had once been laughed at, now buried under praise. Sergeant Curtis Culin was pulled from the front lines and reassigned to engineering detachments, moving from one tank depot to another, teaching others how to build what he had invented. His name spread through every armoured division. Some called him the mechanic who freed the tanks, others the man who broke Normandy. He didn't feel like either. Each day, he worked in workshops that smelled of oil, smoke, and heat. He drew chalk lines on the hulls of tanks, explaining the angles that mattered 15 degrees down for the perfect bite. No more, no less. He corrected welders, measured alignment, and gave the same warning to every team. Too high, and you expose your belly. Too low, and you just dig dirt. Hit it clean like cutting bread with a blade. When the teams succeeded, he nodded once, expression unreadable. When they failed, he picked up the torch and showed them how himself. The war machine moved faster because of him, yet the faster it moved, the heavier his thoughts became. The battlefield had changed, but so had the cost. With their newfound mobility, Allied commanders pushed harder, faster. Places that would have been impossible to reach weeks earlier were now taken by storm. The advance was merciless, calculated, industrial. Culin saw the reports come in. Success after success, but each victory was written in human loss. Every town captured, every line broken, meant more bodies in the fields, Allied and German alike. His invention had made killing efficient. One evening, in a half-destroyed barn turned into a field workshop, Culin sat in silence with Private Eddie Kowalski, one of the first welders who had helped him on the beaches. Outside, the sky glowed orange from distant artillery. "You don't look happy, Sarge," Kowalski said. Culin stared at the floor. "I keep thinking I made a tool to save lives, but all it did was make the war move faster. Maybe that just means the dying moves faster too." Kowalski leaned back against a crate. "You gave us a way to fight back. You saved tank crews, infantry, engineers. Don't twist it. The war's the war. You just made sure more of our boys go home." Culin didn't reply. His torch still sat on the table beside him, streaked with soot, the same one he'd used to weld the first prototype. It looked harmless, but he couldn't shake the thought that every spark from that torch had also lit new fires across Normandy. A week later, General Omar Bradley returned, this time to award him the Legion of Merit. Before a crowd of soldiers and officers, Bradley spoke of ingenuity, courage, and the American spirit of innovation. "This man," he declared, "took scrap and turned it into victory." The applause was thunderous. But when Culin saluted, his hands didn't stop trembling. Later, when the ceremony ended, he approached Bradley quietly. "Sir," he said, "I don't know if I deserve a medal for something that killed people faster." Bradley looked at him for a long moment. "You're thinking like a man, not like a machine. That's good. But remember, these tools don't decide what they do. Men do. You gave us a weapon that saves lives when used right. That's all any invention can promise." Culin nodded, but the words felt heavy. As August bled into September, the Allies broke through Normandy entirely, racing across France. The countryside that had once trapped them now fell open in wide, swift corridors of steel. Every Sherman tank rolling forward bore the ugly, sharp silhouette of Culin's design. It had become so standard that new tanks from the United States arrived with welded brackets already fitted for hedgerow cutters. The field invention had become factory doctrine, but in that triumph was the seed of something colder, the realization that war absorbed everything, even creativity. Innovation was no longer a matter of imagination. It had become a reflex of survival. Each problem demanded a faster fix. Each victory demanded a more efficient way to kill. Culin began to see the war not as a battle of nations, but as a feedback loop, a machine that fed on human ingenuity. Every solution created the need for a deadlier one. One night, While traveling with an engineering team near Saint-Lô, he confided to the unit's chaplain, Father Thomas O'Brien. "I thought fixing the tanks would make the fighting stop," he said quietly. O'Brien watched him carefully. "No, Sergeant. It only made men more capable of fighting. But that's not sin. It's the nature of war progress in the service of destruction." Culin sighed. "Feels like I taught steel to think. But all it learned was how to kill faster." The chaplain shook his head. "No. You taught men to survive. There's a difference. The problem isn't that steel learns, it's that we never stop teaching it." Culin looked down at his grease-covered hands. "Maybe that's the curse of mechanics. You don't just fix things. You make them better at doing what they were built for, even if what they were built for is death." By late autumn, the Culin Cutter had reached every front from Normandy to Belgium. In the chaos of the Ardennes, tanks even used them to push through snowbanks and barricades. The Invention had transcended its original purpose, a weapon turned universal tool, but its creator was growing invisible. The war machine didn't need its mechanic anymore. It had absorbed his idea, standardized it, multiplied it, and moved on. Culin, promoted to technical sergeant, continued to train welders and mechanics, but the sense of ownership was gone. The system had swallowed the man. His invention had become doctrine. His name had become a footnote. And in that silence, the true collapse revealed itself not on the battlefield, but inside the man who had rebuilt it. He had proven that a single idea could change a war. But he was beginning to see that no idea, however brilliant, could change war itself. Every machine carries the logic of its maker, and every war reveals what that logic truly means. The Culin Cutter was not a marvel of engineering. It was crude, uneven, almost ugly. 4 shards of scrap welded onto a tank's face. But in that ugliness lived the purest expression of industrial truth. That progress doesn't emerge from perfection, it is born from desperation. When people look at innovation, they imagine laboratories and blueprints. But the war in Normandy proved otherwise. Real invention happens in mud, not marble. It begins where systems fail, where rules collapse, and where one human mind refuses to accept the way things are. Curtis Culin's torch had not just melted steel, it had melted the boundaries between logic and survival, between creativity and chaos. His idea did not come from theory or doctrine, it came from the oldest form of intelligence, necessity. And necessity is the true engine of civilization. The irony was that the same civilization that built cathedrals, railways, and skyscrapers had now turned its ingenuity toward the craft of destruction. Yet, through that destruction, humanity was learning something profound, that creativity is morally neutral. It serves whatever hands hold the torch. Culin's invention, like the tank itself, embodied the paradox of progress. The same skill that builds can destroy. The same intelligence that saves can kill. What determines the outcome isn't the design, but the intention, the doctrine behind the machine. In Normandy, Allied doctrine had shifted overnight. The war was no longer about brute force. It had become a war of adaptation, of problem-solving, a test of which civilization could re-engineer itself faster under pressure. The Germans had mastery of precision. The Allies had mastery of improvisation, and it was improvisation, not perfection, that won the war. Culin's torch symbolized that transformation. It wasn't about genius, it was about permission, the moment when a system allows one man to try something different. That was the hidden strength of the Allied industrial machine, the freedom to let chaos create order. War, in that sense, was a mirror held up to civilization itself. The same instincts that drive an army to adapt under fire are the ones that drive societies to survive industrial collapse, economic disaster, or technological revolution. It is always the same sequence: crisis, contradiction, invention, expansion, collapse, renewal. Culin's story fit perfectly into that rhythm. The crisis was the hedgerows, the contradiction, a tank that couldn't move, the invention, a welder's blade, the expansion, mass production, the collapse, the moral weight of efficiency, the renewal, the understanding that progress is not clean, That cycle defines every era of industry, from steam to silicon. The lesson is always the same. You don't win by avoiding failure. You win by learning to weld it into something new. To Culin, the irony was cruel. His greatest achievement had also made him obsolete. Once the cutter became standardized, he was no longer needed. The idea had been absorbed, processed, and reproduced like any component in the war machine. In a letter written to his wife in late 1944, he described it with mechanical precision. They took the design, made it official, and built thousands. I suppose that means it worked, but when a man's idea becomes a system, he disappears inside it. Maybe that's the price of progress, that the creator gets consumed by the creation. He was right. The industrial world doesn't remember names, it remembers results. Every revolution in machinery buries the man who started it, but that anonymity is also a form of victory. Because when invention becomes invisible, it means it has become normal, a part of civilization's fabric. The same principle applies to every great leap forward, from the assembly line to the internet. What begins as rebellion ends as routine. Culin's act of welding was more than technical. It was philosophical. He proved that the smallest piece of insight, the right angle, the right cut, can alter the trajectory of vast systems. That is the essence of industrial civilization. Individual intelligence scaled to collective transformation. Years later, historians would describe his invention as one of the small miracles of World War II, a field-borne solution that saved untold thousands of lives. But few understood the deeper implication, that war itself is an engine for innovation because it collapses the distance between necessity and action. In peacetime, invention passes through committees. In war, it passes through survival. And in that crucible, progress becomes brutally honest. Every failure burns away what's unnecessary, leaving only what works. That was the world Culin represented, not the glamorous myth of the genius inventor, but the reality of industrial man. The worker, the problem solver, the one who doesn't theorize about change but builds it with his hands. He was proof that civilization advances not by visionaries at desks, but by mechanics in mud. But perhaps the final lesson was more human than mechanical. Every torch burns two ways: it welds and it destroys. Every idea carries both creation and consequence. Culin had given steel a new function, but he couldn't control what men did with it. And that is the tragedy and triumph of industrial progress. Once born, an idea no longer belongs to its maker. The machine learns to think, and then it thinks without you. In the end, the crazy mechanic wasn't a symbol of madness at all. He was the personification of the human condition in the industrial age, trapped between intellect and instinct, between purpose and consequence. His invention revealed not just how to conquer a battlefield, but how civilizations reinvent themselves in crisis, not through power, but through adaptation. That is the doctrine written in sparks and steel, the industrial philosophy of survival. May 8th, 1945. Germany surrendered. The guns fell silent. Curtis Culin stood beside a Sherman tank in a French field, no longer burning, no longer breaking. The air smelled of rain and diesel. Around him, soldiers laughed, shouted, cried, yet he felt none of it. The war was over, but his mind was still inside the machinery that had carried it there. The hedgerows that once seemed eternal now lay flattened, reduced to scars across the earth. He watched them like a man studying the anatomy of a vanished monster, and realized that his invention had outlived its reason to exist. The Culin Cutter had done its work. Its blades had split France open, paved the way to victory, and then vanished into routine. A year ago, it had been a miracle. Now, it was just another attachment. When he returned home to New Jersey in late 1945, the world was rebuilding. The factories that had once made tanks were now producing cars, refrigerators, and radios. The same furnaces that had poured steel for war now fueled comfort and convenience. Culin went back to his old garage, the smell of oil and metal oddly familiar, almost comforting. He repaired trucks, tuned engines, and replaced worn belts with the same hands that had welded blades for tanks. People in his town knew him as Kurt, a quiet mechanic who didn't talk much about the war. When someone recognized his name from a newspaper article and asked if he was that Culin, he only shrugged. "Yeah," he'd say. "I fixed some tanks." To him, that was the truth. He had fixed something broken. The world just happened to call it history. Years later, as the Cold War began, Culin watched a new generation of machines rise faster, larger, more intelligent. Tanks with computers, missiles guided by radar, engines run by mathematics instead of instinct. He never criticized it, but sometimes, while closing the garage late at night, he would stare at the sparks from his welding torch and wonder whether anyone still understood what it meant to build something, to feel the weight of metal, the smell of fuel, the pulse of heat through your gloves. To him, invention was never about theory. It was about listening to the world through steel. History barely remembered him. His name appeared in technical manuals, footnotes, and occasionally in military documentaries. But in the museums of America and Europe, the Culin Cutter still hangs 4 crude blades of rusted iron welded to a fragment of a Sherman hull. There is a small plaque beside it. Field Innovation, Normandy, 1944. Developed by Sergeant Curtis Culin. Enabled Allied armor to breach the hedgerows. AMCAA. Visitors walk by, read it, nod, and move on. But that piece of metal still hums with something older than memory, the echo of a man's defiance, captured in steel. A historian once asked him, near the end of his life, if he understood the magnitude of what he'd done. "Thousands of lives saved," the historian said. "Weeks cut from the campaign. You changed history." Culin paused for a long time before answering. "I didn't change history," he said quietly. "I changed one idea that a problem was impossible. That's all invention really is. The rest belongs to whoever uses it." He smiled faintly. "If there's any lesson in it, it's this: you don't need permission to fix what's broken." When he died in 1963, his obituary was short. It mentioned that he was a veteran, a mechanic, a husband. It did not mention that he had altered the course of the largest war in human history. But perhaps that was fitting. Because Culin's work was never about glory. It was about logic, necessity, and the will to build. And in that, his spirit lives in every welder who turns scrap into purpose, every engineer who sees failure as design waiting to be corrected, every civilization that claws its way out of ruin with sparks instead of prayers. The world he helped create is still made of the same materials: steel, ambition, and the endless noise of progress. Somewhere in that noise, if you listen closely, you can still hear it. The faint hiss of a welding torch in Normandy, and the sound of a crazy mechanic teaching the machine to think.